Welcome to part 2 video. Now here real quick, this is where we ended off. We are going to look at our next type of special sequence. It's called a recursive sequence. Again, it's a function, but now the next term in the sequence is predetermined by the values of the previous terms, not the value of n. So what does that mean? If I was working with this function right here, and I wanted to find what is a sub 20, the 20th term in the sequence, I would just put 20 in for n. 2 times 20 is 40, minus 1, 39. That would be the 20th term. However, here, you're going to have to find the first term, the second term, the third, the fourth, the fifth, because you have to find the terms before it. You either add, subtract, multiply, divide them to find the next number. So here what happens in the definition usually has a couple terms defined. A sub 0 is 1, a sub 1 is 1, a sub n is equal to a sub n minus 2 plus a sub n minus 1, where n is going to be greater than or equal to 2 when we want to use this function. So here's my sequence so far. A sub 0 is 1. A sub 1 is 1, 1 comma 1. So they've first two terms of my sequence. This case they decided to start with 0 for the n. Now, to start using this function, n has to equal 2. So that means this 2 goes in for this n, so that's a sub 2. Then 2 minus 2 for this a, plus a sub 2 minus 1, that's this term. So a sub 0 plus a sub 1. So in essence, the next term in the sequence says you've got to go add the two previous terms together, and that's the next term in your sequence. Then when n is equal to 3, we put a 3 here for this n, a sub 3 minus 2 plus a sub 3 minus 1, which becomes a sub 1 plus a sub 2. Okay, that's 1, and this 2. 1 plus 2 is 3. When n is 4, a sub 4 is going to be a sub 4 minus 2 plus a sub 4 minus 1. That's 2. That's a 3. A sub 2 plus a sub 3. Okay, a sub 2, that's the 2. A sub 3 is 3. 2 plus 3 is 5. Wait a minute. 1 plus 1, that was the two previous terms. There's a pattern here. The 3 came from the 1 and the 2. The 5 is coming from the 2 and the 3. There it is. 1 plus 1 is 2, gives me the next one. So it looks like what I'm doing is I'm adding the two terms before the one I want to get my next term. So 1 plus 2 is 3. 2 plus 3 is 5. I see the pattern. So 3 plus 5 is 8. 5 plus 8 is 13. 8 plus 13 is 21. So as you can see, I can't just plug in a 20 and find the 18th and 19th term to add them together because I got to go find them first. So first, second, third, fourth, fifth, sixth, seventh, eighth. That's the 8th term. I just got to keep going until I find all the way out to my a sub 20 if that's what I want. Our next special sequence is called factorial notation. So if n is a positive integer, n factorial, that's the exclamation point, is defined as n factorial equals the n times n minus 1, take 1 away from the n, times, now take 2 away from the n, and you keep taking away 1 each and every time until you get down to 1, and you multiply all these numbers together. So our special cases for our factorials is going to be 0 factorial by definition will be a 1. 1 factorial will be 1. So if we wanted to write out a bunch of factorials here, so 2 factorial, that's the 2 times the 1, that's 2. 3 factorial, 3 times 2 times 1. 6. You just start at the number that's on your factorial, count backwards to 1, multiply them all together. 4 factorial, 4 times 3 times 2 times, wait a minute, 3 times 2 times 1, 3 times 2 times 1 is right there. I could just take the previous answer, 6, and multiply it by, hey, this is a recursive sequence. Take the last number, multiply it by 4, 24. Take the 24, multiply it by 5, because there's your 4, 3, 2, 1, multiplied by 5, 120. 6 factorial, 6 times 5, 4, 3, 2, 1, which we did up here. So 6 times 120, 720. That's a way you can find your factorials. All right. Find the first 5 terms given by a sub n is equal to 2 to the nth power all over n factorial. And we want n to start with 0. So a sub 0 is equal to 2 to the 0 power over 0 factorial. Well, 2 to the 0 is a 1. By definition, 0 factorial is a 1. 1 over 1 is 1. A sub 1, 2 to the first, that will be 2. 1 factorial, 1. Simplifies to a 2. A sub 2, 2 to the 2 powers, 4. 2 factorial is 2. 4 divided by 2 is 2. Find a sub 4, 2 to the third, 8. 3 factorial, 6. 8, 6, which reduces to 4 thirds. Now, at some point, again, you might find a pattern. 2 to the 0, 2 to the first, 2 to the fourth, 2 to the third. Oh, I'm just taking the previous numerator and multiplying it by 2. 2 times 2, 4. 4 times 2, 8. So down here, 8 times 2 would be 16. And then we can do the same thing with our factorials. Take the 2, multiply it to the previous denominator 1 for 2. Take the 3, multiply it to the 2, 6. Take the 4, multiply it to the 6, 24. 16 over 24. That's my pattern, which reduces this to 2 thirds. So look at the first fraction you create for your pattern, not the reduced one. All right, simplifying factorials by hand are probably easier than doing this in your calculator technically. All right, so if I had 8 factorial over 2 factorial times 6 factorial, find the largest factorial on both top and bottom, 8 and 6. Since 8's bigger than 6, I'm going to count backwards from 8. 8 times 7 times 6 factorial. I stop. Now granted, I could go 6 times 5 times 4 times 3 times 2 times 1. And the 6 factorial on the bottom would be 6 times 5 times 4 times 3 times 2 times 1. But my question is, why write out an extra 5 factors, another 5 factors on the bottom, just to slash them out? We can just cancel the 6 factorial. And the 2 factorial, since it's not going to match up with anyone on the top, we'll just list this out as 2 times 1. And so that way the 2 can go into the 8 4 times. My 6 factorials cancel each other out. 4 times 7 is 28. I'm done. And we can do this twice. All right, again, biggest factorial top and bottom, 6 and 5. 6 factorial, count backwards to 5 factorial. Those are done. Now 3 and 2. 3 is bigger. Count 3 backwards until it hits 2 factorial. Then stop. So it looks like this. Here's my 6 factorial. 6 times 5 factorial. Stop. It's a match. On the bottom is 3. I count backwards. 3 times 2 factorial. Stop. It's a match on the top. We got all kinds of canceling. 2 factorials cancel. 3 can go into 6 twice. 5 factorials cancel. Oh, the answer is 2. 2 over 1 is 2. And if they give you variables, don't panic. We can still do this. N factorial, remember the definition on the previous slide, is n times, now n minus 1. Hey, that matches the bottom. Sorry about this factorial blending in over here. So that's now n minus 1 factorial. With this n minus 1 factorial, they cancel out. The answer is n.